All right, welcome back everybody. Today we're going to be talking about what we call special right triangles. There are two types of special right triangles. There are triangles that we call 30, 60, 90 triangles, and that's all based upon the degrees that are in each triangle, and 45, 45, 90 triangles. Now our objective today is that you're going to be able to determine the missing lengths of a special right triangle using the relationships of a 30, 60, 90 triangle and a 45, 45, 90 triangle. Now, here are the two special right triangles that we talk about. We call this first one a 30, 60, 90 triangle because of the fact it has degrees in each of the corners of 30, 60, and 90. Now, there are special relationships in a special right triangle pertaining to the degrees and its sides. So when we look at a 30, 60, 90 triangle, we obviously will have our hypotenuse that is still going to be located across from the right angle. We will have a long leg, which will be this one, right, because it's longer than the other one, and then we'll also have a short leg. Now, the formulas that we need to remember for this one, or what we need to realize about this, is that everything depends upon the short leg. As soon as you know the short leg, then you can very easily figure out the hypotenuse, and you can very easily figure out the long leg. And since we don't know the short leg's length, we're just going to call it x. Now, depending on what the short leg is, the hypotenuse will always be double it. So whatever the short leg is, if you double it, you will get the length of the hypotenuse. And if you multiply whatever the length of the short leg is by the square root of 3, you will get the length of the long leg. Now, I like to normally convert these into simpler formulas. So the hypotenuse is always equal to 2 times the length of the short leg. And the long leg is always equal to the square root of 3 times the length of the short leg. We'll be using those formulas quite a bit. Sometimes you might know the hypotenuse and you need to work backwards to solve, but those are going to be the basis of our understanding today. The triangle over here on the right, this is what we call a 45, 45, 90 triangle because it has two 45-degree angles and one 90-degree angle. The hypotenuse is still located right across from the right angle. And we just call these legs in this problem. Now, the nice thing about a 45, 45, 90 triangle is that this leg is always the exact same length as this leg. There's one formula here that we utilize, and that is a relationship from the length of a leg. So if our leg length is x, we know that the hypotenuse of this, based upon the fact it's a special right triangle, will be x times the square root of 2. So our formula for a 45, 45, 90 triangle is that the length of the hypotenuse is always going to be 2 times the length of a leg. And there is no short or long leg here because they're the same distance or same length. So let's look at a problem. Here we have a 30, 60, 90 triangle. Oh, I'm sorry. This is just actually a diagram of what we were saying up there, right? So if I take the short leg and I multiply it by 2, I get to my hypotenuse. If I take the short leg and I multiply it by the square root of 3, I would get to my long leg, right? This is basically saying these two rules over again for us. Same thing with the other one. Depending on if it's a 45, 45, 90 triangle, if I take a side length and I multiply it by the square root of 2, that will give me my hypotenuse, which is the same thing as this rule that we developed up above. Let's talk about how we use these rules. So coming over here now, it says using special right triangles, complete the triangle, right? Can find the missing part. So when I come over here right away, if this is a 90-degree angle and this is a 45-degree angle, I know this has to be a 45-degree because that's the only thing that would add up with that to make this into 180 degrees that every triangle has in it. Now, when I look at this problem, I notice that my side length here is 7. That means the bottom of this triangle is also going to be 7. Now, since we're dealing with a 45, 45, 90 triangle, the only rule that we actually have to work with is this one. That my hypotenuse is equal to 2 times, I'm sorry, the square root of 2. I don't know why I didn't put the square root on that. I gotta go back. Square root of 2 times the leg, square root of 2 times the leg. Put square root up here. I just didn't copy it down right. So our hypotenuse is going to be equal to the square root of 2 times whatever our leg length is. Well, in this problem, we want to find the hypotenuse, so that's we could just call x. So x is going to be equal to the square root of 2 times whatever the leg length is, which is 7. Now, this is an inside number and this is an outside number, so I'm not going to be able to just multiply 2 times 7. Instead, that 7 is going to sit in front, so x will be equal to 7 square roots of 2, just like that. Looking at the next problem, this one is like the harder version of the same problem. Again, we'll have our formula here. Once you know the kind of triangle you are working with, this is a 45, 45, 90 triangle, then you want to grab any formulas that may pertain to that. Now in this situation, I know what the hypotenuse is. The hypotenuse of this is 5. So 5 is equal to the square root of 2 times my leg length. Now in this situation, I don't know what my leg length is, so we're going to give it the variable name of x. Now the way we wanted to solve this is, since the square root of 2 is hooked onto that by multiplication, to unhook it, we are going to divide. That will mean these two pieces cancel out, and ultimately x will be isolated by itself. Now in doing that, we create a different problem because we have 5 over the square root of 2, and that will need to be rationalized. So to rationalize it, I'll multiply by the square root of 2 and the square root of 2, and that will leave us with 5 square roots of 2 over 2. Because the square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. So my final answer here is that x is equal to 5 square roots of 2 over 2. And that is our answer. Let's take a look at some 30, 60, 90 ones. Again, I'm going to go up and grab my formulas so I can start this. So, in this situation, this 14 is my short leg. And we're being asked to find everything else to complete the triangle with the exact values. So if this is 30 degrees and this is 90 degrees, then up here this has to be 60 degrees. Now, since we are being given what the short leg is, we can use that to find the hypotenuse, right? The hypotenuse is just whatever the short leg is times 2. So 14 times 2 means our hypotenuse is going to be 28. Now, you can go about finding the other quantity however you want. Some people would use the Pythagorean theorem here, but since it's a 30, 60, 90 triangle, it's actually really easy to do using our other formula. So the other leg, this is our long leg, is just going to be equal to the square root of 3 times whatever the short leg is. Well, our short leg was 14, so 14 times the square root of 3 will be the length of our long leg. So at this point, we have went through and we have found all the missing pieces of information for that triangle. Here's our next one. In this one, we know it's a 30, 60, 90 triangle, because if this is 30 and this is 90, then this has to be 60. And we already know our hypotenuse. Now, since everything goes through the short leg, we're going to use our formula that talks about the hypotenuse to figure out what the short leg's length is. So in this situation, since 12 is our hypotenuse, 12 is going to be equal to 2 times, let's just call this x. We'll call this one y. So to solve this, we're trying to get x alone, so I want to come over here and divide by 2, and divide by 2, and I'll find out x equals 6. So this is equal to 6. Looking at the bottom of that triangle, we're looking for our long leg. So let's pull in our long leg formula. So our long leg, which we don't know, we gave it the name of y, so y is going to be equal to the square root of 3 times whatever the short leg is. The short leg we just figured out was 6. So this is going to be the square root of 3 times 6, which we can say better as 6 square roots of 3. So we've now went through and found all of the missing angles and sides for this triangle using those formulas, and it doesn't take all day and it's relatively quick. Here's our last problem. Now, our last problem of this set. So when I look at this problem, here's what I need you to consider. Right now, we are being given a 60-degree angle. And that means that this will be our 30-degree angle. What you need to know is that across from the bigger angle is always going to be the bigger side. So this will be our long leg, and this will be our short leg. Right now, we know our long leg, so we need to use our long leg formula. And our formula says that the long leg is equal to the square root of 3 times the short leg. Since we don't know what the short leg is, we're going to solve it to figure that piece out. So in this situation, since the long leg is 10, we can replace LL with 10. So 10 is equal to the square root of 3 times the short leg. If I want to find the length of the short leg, I need to get rid of the square root of 3. So I'm going to divide both sides by it. These two will cancel off. So I'm left with 10 over the square root of 3 is equal to the short leg. Now, this is not rationalized, so we're going to have to do some extra work to rationalize it. So to do so, we are going to come over here and multiply by the square root of 3 over the square root of 3. 10 times the square root of 3 will be 10 square roots of 3. And on the bottom, the square root of 3 times the square root of 3 will give us just 3. So 10 square roots of 3 over 3 is the length of the short leg. So down here, I'm going to move this down. We can say 10 square roots of 3 over 3 is that distance. Now, to figure out the hypotenuse, we just need to take whatever the short leg is and double it. So maybe easier said than done at this point because this short leg looks kind of ugly. But we do know that our hypotenuse is equal to our short leg times 2. So if I want to find my hypotenuse, we can keep it as HYP. This is just equal to our short leg times 2. Our short leg, like we found, was 10 square roots of 3 over 3. And we want to multiply that by 2. Now, to do this, we can think about 2 as 2 over 1. 2 times 10 is going to give us 20 square roots of 3. 1 times 3 is going to give us 3. And this will be the length of our hypotenuse. So our hypotenuse here will be 20 square roots of 3 over 3. Let's take a look at some 45, 45, 90 triangles quickly. So looking at these two, find the length of the missing sides of the triangle. Right now, we're being given the hypotenuse. Our formula for this is that our hypotenuse is equal to the square root of 2 times a leg. So we don't know what our leg length is. That's what we're actually trying to find over here in this problem. So if we know that, or know this formula, then we can replace what we know the hypotenuse is 20, is equal to the square root of 2 times x. And all we need to do to figure out what x is we need to just come over here and divide by the square root of 2 and the square root of 2. So 20 divided by the square root of 2, we need to rationalize it, so we're going to multiply by the square root of 2 over the square root of 2, and that's going to give us 20 square roots of 2 over, let's just say the square root of 4, which is going to become 2. And then 20 divided by 2 is going to become 10 square roots of 2. So x in this problem is going to be 10 square roots of 2. And since it's a 45, 45, 90 triangle, these two lengths are the same. So this up here will also be 10 square roots of 2. Now as we move over here to this other triangle is a 30, 60, 90 triangle. We're being given our hypotenuse. What we should know about a 30, 60, 90 is that if we know the hypotenuse, dividing it by 2 will give us our short leg. So 8 divided by 2 means that our short leg is going to be 4. Once you know your short leg, you just need to multiply it by 3 to figure out the long leg. Or I'm sorry, the square root of 3. So 4 times the square root of 3 will be 4 square roots of 3. And we're done. Right? So knowing these two tricks allows us to solve for missing lengths of a triangle very quickly, and that's going to be important as we start to move into the trig portion of pre-calc. Looks like we have a couple more problems here. So in this one, a 45, 45, 90 triangle. Our formula is that the hypotenuse is equal to the square root of 2 times a leg. So to solve this, we know the hypotenuse. So I'm going to have 12 is equal to the square root of 2 times a leg. We're trying to find the leg length here. So to do so, we need to divide by the square root of 2 on both of these. 12 divided by the square root of 2. We need to rationalize it since we have a square root on the bottom. So this will be 12 square roots of 2 over 2, which will reduce to be 6 over 1. So our final answer here will be 6 square roots of 2 is what our leg length is. So this goes here and here. And of course, this is still 45 degrees. Looking down here at this bottom one, this is, we can see a 60-degree angle, so we know this is a 30, 60, 90 triangle. Since the 60 opens up to the side of 6, this is our long leg, which means this will be our short leg, and this will be our hypotenuse. Now, there's no relationship between the long leg and the hypotenuse, so what we need to do is we need to start with our long leg, figure out our short leg, and then figure out our hypotenuse. So, to do so, let's use our long leg formula. We know that our long leg is equal to our short leg times the square root of 3. In this situation, our long leg is 6. So I'll have 6 is equal to our short leg times the square root of 3. And we want to find the short leg, so let's divide off the square root of 3. So our short leg is equal to 6 divided by the square root of 3. Now, we do need to rationalize that, so we're going to multiply by the square root of 3 square root of 3. So I will end up with, I want to just move over this equal, 6 square roots of 3 over 3, which will reduce down to be, since this is 1 and 2, 2 square roots of 3, which is equal to our short leg. So our short leg down here is going to be 2 square roots of 3. Now, to jump from our short leg to our hypotenuse, we know that our hypotenuse is just equal to our short leg times 2. Since our short leg is 2 square roots of 3, we can replace that. So 2 square roots of 3 times 2 is equal to our hypotenuse. And then to finish solving that, we just need to come over here and multiply. 2 times 2 is going to give us 4 square roots of 3 is what our hypotenuse is. So our hypotenuse will be 4 square roots of 3. Now, these last two problems that I have here for you, these end up being a little bit more of like a puzzle-esque problem, but we can still use that to solve. So coming over here, let's do this top one first. I like to think about this problem first as if there's only one triangle. So I'm going to erase this middle stuff here. And if I were to do that, then I would quickly realize that I'm working with a 30, 60, 90 triangle. Now, right now, I know what the short leg is. So let's figure out the long leg. Well, to get from the short leg to the long leg, I just need to take whatever the short leg is and multiply it by the square root of 3. So I know right there that my long leg on this is 10 square roots of 3. Now, the nice part about doing that is that when I get rid of this and I can see my other triangle, now I can think about it as if this part is not here. And if I get rid of that part and I don't even think about any of it, I should have enough information to solve this. Right now, I know what the long leg is. Or I'm sorry, what the hypotenuse is. So if I know the hypotenuse, I know that the hypotenuse is equal to 2 times the short leg. Now, since my hypotenuse is 10 square roots of 3, that's going to be equal to 2 times the short leg. If I want to find the length of the short leg, which would be this region right here, I could divide by 2 and divide by 2, and I will end up with 5 square roots of 3 is equal to my short leg. So right here, this side is 5 square roots of 3. Now, the last part of this involves finding the long leg. So since this y is representative of our long leg, what we need to do is use our long leg formula. Our long leg is equal to our short leg times the square root of 3. Since we don't know our long leg, we can give it a variable name of x. Our short leg, though, is 5 square roots of 3. So 5 square roots of 3 times the square root of 3 should be equal to x. Multiplying this out, I'll get 5 square roots of 9. The square root of 9 is, of course, just 3. So this will be 15. So x ends up being equal to 15. So in this situation, y will be 15. Like I said, this one's like more of a puzzle-esque problem. Looking down here at this last one, we can see that we have two triangles back to back. This first one is a 45-45-90, and this other one is a 30-60-90. Now we're going to start over here since I know the hypotenuse of the 45-45-90 triangle. When I talk about 45-45-90 triangles, the rule I use is that the hypotenuse is equal to the square root of 2 times the leg. I know the hypotenuse is 8, so 8 has to be equal to the square root of 2 times whatever the leg is. Since I'm trying to figure out the length of the leg, let's divide off the square root of 2 on both sides. That will isolate the length of the leg. 8 divided by the square root of 2, we'll need to rationalize, so square root of 2. Square root of 2, this will be 8 square roots of 2 over 2, which will reduce to be 4 and 1. So 4 square roots of 2 will be the length of our leg. Now, the reason that's helpful to us is because in this problem, if that's 4 square roots of 2, then I know that this length will be 4 square roots of 2. And I also know that this length will be 4 square roots of 2. Now, since the 30 opens up to this length, I know that this length is the short leg of this triangle, the yellow one here, or highlighted. So, using that short leg distance, I'm going to use my formulas here. I know the hypotenuse of a 30-60-90 triangle is equal to the short leg times 2, and I know my long leg is equal to my short leg times the square root of 3. So, in this situation, my short leg is 4 square roots of 2 times 2. So 2 times 4 means that my hypotenuse will be 8 square roots of 2. For my other problem, 4 square roots of 2 is the length of the short leg times the square root of 3. 2 times 3 will give us 4 square roots of 6, which will be the length of our long leg. Right, so we really get to some problems where you got to do a little bit of work to actually get through and get to that information. But with that being said, I don't have anything else for you. Today you're going to be working with these two triangles primarily. Those rules are going to be very important for you. If you have any questions, please do not hesitate to reach out. Remember, I'm always here to help. Thank you guys so much for watching the full video. Let me know if you need anything.